Hello everybody, this is Carlos from Army of Nurses and welcome to another video. In this video we will be discussing basic cardiac rhythms, the normal sinus rhythm, which is the normal rhythm of a healthy heart. Now, in order to be able to understand pathology and abnormal rhythms of the heart, we need to get an appreciation for what is normal first. Some of the things that we will be discussing include a review of the electrical pathway of the heart, interpreting lead 2, the significance of the ECG paper grid, the 1500 rule, and some of the criteria that must be met for a rhythm to be called normal sinus rhythm. So the SA node located in the right atria, in the upper part of the right atria, is the pacemaker in the heart. Once the electricity gets originated, the signal gets originated from the SA node, it travels through the atria down to the AV node, the atrioventricular node, where it stops briefly for a fraction of a second. Now, this stopping has a clinical significance because it allows for more blood to enter the ventricle, so that there is more cardiac output. The signal continues to travel through the down through the bundle of His, through the bundle branches, and then the Purkinje fibers. Now, if we can actually have a look at this image, that we can see that the signal travels from the from the left upper part of the screen all the way down to the right lower part. Okay, and this will have a clinical significance a little later on. Now, the traveling of this electricity in that pattern, it creates the PQRST waves in the ECG, and they look like this. Okay, now the P wave, represents atrial depolarization, and depolarization is another term for contraction. And then we have repolarization, which is another term for relaxation. So depolarization, DE, contract; repolarization, RE, relax. We're going to be using contract and relax just to make this video a little more user friendly. So when the atria contracts, it creates the P wave. Now the next is the QRS. That's when the ventricles contract. When the ventricles contract, they create this spike called the QRS. The T wave represents the ventricles relaxing. So if you look at the QRS waves here, you can see atrial contraction, ventricular contraction, and then ventricular relaxation. So you might be asking, where's the atrial relaxation then? Well, the atrial relaxation happens simultaneously during the time when the ventricles contract. And because the ventricles are so big, so powerful, they have so much muscle in them, the force that the ventricles contract, when they contract and they create the QRS wave, it completely overshadows the atrial relaxation wave. So it is understood that the atria relaxes inside the QRS because the P wave, the atria contracts, and then it needs to relax. But because the ventricles contract right at the same time when the atria is relaxing, it doesn't show in the QRS because the QRS from the ventricle is so much more strong that completely overshadows that. One thing that we will have to focus on is this little interval from the beginning of the P wave right until the beginning of the R wave, and we call it the PR interval. Okay. Now, the other interval that we're going to be looking at is the little complex, the QRS. Mainly, it's called a QRX because it consists of the Q wave, R, and S wave right here. So we call it the QRS interval. Okay. Next, we're going to interpret lead 2. But so why lead 2 though? So this is based on Einthoven's triangle and the principle of vectors. So vectors is just a fancy name for the direction in which the electricity or the electric current flows in. So in this case, I drew a triangle here with RA representing the right arm, LA representing the left arm, and LL representing the left leg. Now, as you can see from lead 1 here, the electricity, the vector, is traveling from the right arm to the left arm. Lead 2 is traveling from the right arm to the left leg. And lead 3 is traveling from the left arm to the left leg. Now, if you ask yourself which one of these 3 leads closely resembles the electrical pathway in the heart, where the SA node where the signal starts at the SA node and then travels through the heart and ends up in the Purkinje fibers, then lead 2 is the one that closest resembles that, because then we have electricity traveling from the left upper part here of our screen, following all the way down to the right lower part of it. So which is why we use lead 2 to interpret our leads. Okay. Now the significance of the ECG paper grid. And this is important because our ECGs will be printed on paper, and you will see that they come up in little strips. And so let me introduce you to some of the features of the paper. It's a whole bunch of little squares, and then they're merged together into big squares. Okay, so to make it more visible, here I have separated them in. I have separated the big squares from the tiny square. So one tiny square will be equal to 0.4 seconds. Okay, one tiny square, this one. And then one large square, which consists of 5 tiny squares, will be 0.2 seconds. So if you don't know how I got that number, if one tiny one is equal to 0.04 and then a big one consists of 5, then I'm just multiplying that number by 5, which is why I get 0.2 seconds. Okay, now when you put 5 of the big squares together, then you have 1 second, because then you have 0.2, 0.4 seconds, 0.6, 0.8, 1 second. Okay, and this becomes significant because it plays part in the criteria for a normal sinus rhythm. Now I'm going to introduce you to the 1500 rule. This rule is used to determine the heart rate on an ECG strip when the heart rate is not written in a numerical way by the machine. Okay, so the way that we're going to do this is, step number 1, you're going to count the tiny squares between the 2 R's. The tiny squares meaning the 0.04 seconds tiny squares. Okay, now the 0.04 seconds tiny square, when we count the number of those tiny squares between the 2 spikes, between the 2 R's, I'm going to put a picture here. Between this R and this R, between those 2 spikes, there's a whole bunch of tiny squares in there. When you count the amount of tiny squares that there are in between the 2 R's, you're going to divide 1500 by the number of tiny squares. For instance, if, for example, I find 10 tiny squares between the 2 R's, okay, then I'm going to divide 10 from 1500, and it gives me 150. So in this example I'm giving you, the heart rate will be 150 beats per minute. Okay, we have some examples at the end of this video, and hopefully it helps you visualize and connect all the principles together. It's as simple as that. All right, so we're gonna go to the criteria for a normal sinus rhythm. So in order for a rhythm to be called a normal sinus rhythm, a few criteria must be met. 1, the heart rate needs to be between 60 to 100. Anything less than 60, we call it bradycardia. Anything above 100, namely 101 and more, we're going to call it tachycardia. Okay, so 60 to 100 would be our normal heart rate that we're going to look after. Step number 2, between the R to R must be regular throughout. That means that, let's pull out the example here. Between this R and this R, as the example goes by, as the waves go by, this should be regular throughout. Okay, so I'm going to show you one of the examples. Let's go to example 1. As you can see, these R and R and R and R, they all are symmetrical, rhythmic, they happen at the same interval. So that's what we call by regularity. Okay, so that's regular. Number 3, the PR interval must be between 0.12 to 0.2 seconds. Now, if you don't remember what the PR interval was, is this little portion here that we introduced during this graphic. Now, between the PR interval has to be from 3 tiny squares to 5 tiny squares. It has to be anywhere between us. It can be 3, 4, or 5. Okay, so that's the normal range from 0.12 to 0.20. Okay. Next criteria is going to be the QRS interval. It needs to be less than 0.12. Again, this is where we have the QRS interval. So from the beginning of the Q up to the R, down to the S, wait for the S to come back up to the isoelectric line, and this is the part that you're going to count the amount of tiny squares in there. There should be 3 or less, which is 3 tiny squares equals to 0.12 seconds, right? Because remember, 1 tiny square is equal to 0.04, right? So, and that's the criteria that we have. Number 5, the T wave can be up, can be down, but then that's something that we will note because it places significance in interpretation of the rhythm and potential treatments for that. So let's go back to our example number 1. In our example number 1, as we can previously said, is it regular or is it irregular? Well, if we count the R to R's and R to R, we compare all the R to R, they seem to be very symmetrical. They follow a rhythmic pattern. They happen at a very precise interval. So it's regular. So that part of the criteria is met. Number 2, what's the heart rate? So the heart rate, we use the 1500 rule. You're going to count the number of tiny squares between the 2 spikes here. Okay? So when you count the number between the 2 spikes, I got 15 in here. So if you get 15 or 14 or 16, don't worry as long as you are within that. Because remember, it's very hard to have 15 every single square. So the rule is that if you're off by 1 or 2 tiny squares in there, it's still okay. So in this case, we run up to 15. Okay? So if we use the rule, the 1500 rule, 1500 divided by 15, it gives me 100. So 100 is the beats per minute, which is the heart rate. So this rhythm has 100 beats per minute, which under our criteria is still normal sinus rhythm, because remember, our heart rate has to be from 60 to 100, right? So it fills that part up. Step number 3, we look at the PR interval. So we look at the beginning of the P right until the beginning of the R wave. Okay, and so from the beginning of the heel up until the bottom part of the heel here in the P wave. If you count the amount of tiny squares in there, you should get about 4. Now 4, it's equal to 0.16 seconds, right? Which falls within our criteria, which is it has to be between 0.12 to 0.20, right? So then this also falls within our criteria of normal sinus rhythm. Next thing, we're gonna count the tiny squares in the QRS, which is the spike here. So we're gonna start the Q wave, R, S, and wait until the S comes back to the isoelectric line here. So if you count the number of tiny squares, you should get about 3. And 3 tiny squares is equal to 0.12 seconds, which is normal. If it's 0.12 seconds or less in the QRS, then it's part of the criteria for normal sinus rhythm. Okay. Lastly, we have the T wave. The T wave seems to be upward, seems to be normal. So to conclude, this rhythm here is regular, has a heart rate of 100. PR interval is 0.16 seconds. QRS interval is 0.12 seconds, and T wave, they seem to be normal. Therefore, this is a normal sinus rhythm. Okay, example number 2. Same thing, you can go through these steps. We're going to start with the R to R. They seem to be normal. They happen at the same frequency, same rhythm, so regular, yes. Next, we're going to do the heart rate. We're going to count the tiny squares between 2 R's, and I counted 19. So 1500, we're going to use the 1500 rule. 1500 divided by 19, it gives me about 79, which is 79 beats per minute, and that's the heart rate, which falls under our 60 to 100, which is normal. Second criteria met. Number 3, our PR interval. So we're going to count from the beginning of the P wave right until the beginning of the R wave. So we're going to count the little P wave, the little heel. I counted 4 tiny squares, which is 0.16 seconds, 0.16. And it falls between the 0.12 to 0.20, which is normal. Third criteria met. Number 4, we're going to count the QRS interval, the little spike, right? From the Q wave up to the R wave, down to Q, R, S, and then wait for the S wave to come back to the isoelectric line, and I counted 2 tiny squares. 2 tiny squares equals to 0.08, because remember, each one tiny square is 0.04, so we just multiply that by 2, right? And the criteria for the QRS is if it's less or equal to 0.12, then it's normal, and in this case it's 0.08, which is normal. T waves, the T waves, they're upwards, but then they're a little bit peak. So my interpretation of this rhythm strip will be, it is a normal sinus rhythm with peak T waves, right? And the reason why we know the peak T waves is because a lot of potassium imbalances, they could cause some morphology changes in the T waves, and it's something that we should monitor that closely. All right, and the last example, again, we're gonna count the we're gonna look at the R2Rs, right, the little spikes, and they do seem regular in a rhythmic pattern, right? They're not abnormal. Heart rate, we're gonna count the tiny square between 2 Rs, and I got 24. So if we do 1500 divided by 24, I get about 63 beats per minute, which falls between the 60 to 100. Step number 3, the PR interval. Now this one might be a little more challenging to see, but you can still see little blips of the P wave here. So if you count the beginning of the P until the beginning of the R wave right here, you should get about 4 tiny square, which is 0.16 seconds, normal. Next step, we're gonna count the QRS. The QRS is about 2 tiny squares. If you count here from the QRS right here, just 2 tiny squares, 0.08, right? So that's normal. And the T wave, they're nice upwards, so the T waves are normal. Again, my interpretation of this rhythm will be a normal sinus rhythm with a heart rate of 63. Okay. I hope you learned something from this video. If you have any questions, please enter them in the comment. And thank you for watching. And my advice to you would be, in order to be comfortable interpreting rhythms, it's just a matter of practicing. Make sure you follow the criteria in a systematic way. That's the way I learned it in school as well, and it just makes it so much easier because you don't miss a step. So practice makes perfect. If you work in a place that you are able to obtain ECG strips, make sure that you do anonymously, cut the patient's name off, and just practice interpreting some of the rhythms. Alternatively, there are a lot of ECG practice books out there which you can benefit you as well. Again, thanks for watching, and take care until next video. Bye bye.